Well, hey, Living Environment fans, you're back for another episode of the Bellringer and science class. And of course, we're studying DNA, deoxyribonucleic acid, DNA, right? Which is like the stuff of life. It has the genes coded in it, right? And we're mastering this week, our learning target is how does DNA copy itself? So let's look at that.
All right.
Hey now.
Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
Right, so it's key to know, right, that the way the DNA double helix is built, right, the rungs of the ladder are the sugars and phosphates, the rungs of the ladder. What are the rungs made out of again? Yeah, by the way, that sugar is called deoxyribose, O-S-E, the sugar. And then the rungs of the ladder are made out of what we call nucleotide bases, and there are 4 of them: adenine, thymine, guanine, and cytosine. And adenine always pairs with thymine. They always go with T. And guanine always pairs with cytosine. So it's A with T, G with C. A with T, G with C. You see the A's and T have a double hydrogen bond. The G's and C's have a triple hydrogen bond. But hydrogen bonds are what hold them together. So to replicate or to copy one's DNA, first you have to split the strands. You got to bust through those hydrogen bonds. That's done with an enzyme called helicase. Helicase. Helicase is the enzyme that breaks the hydrogen bonds. Helicase. Helicase. Once helicase has split the strand, then all you have to do is match A's with T's, G's with C's, and you'll get 2 complementary strands that are the same as the original ones you started with. Of course, to do this, you need more enzymes. We call these polymerases, which speed up the rate of sticking A's with T's, G's to C's. Okay? And what's weird about it is that DNA polymerase only works in one direction, from the 3 end to the 5 end. So if you think of it, when they're splitting this DNA molecule, right, one strand is easy to make, copy. The other strand you have to copy in pieces. Again, it's not really that important for you to know, but yeah, that's harder to do and more likely to make mistakes. Anytime you have a mistake, what's that called if you have a mistake when you copy a piece of DNA? And of course, as we said yesterday, cells have this life cycle, right? And when they're born, they're little itty bitty cells, and they start growing and making their proteins and doing their celly things. And then, but they all get a signal at some point in their lives, about a third of the way through their lives, that it's time to replicate the nucleus, copy that nucleus. It's called the S phase of their life, the DNA synthesis S phase of their life. And during the S phase, they get a signal to copy themselves. Then when they're done copying their DNA, then they just split in 2, and now you have 2. That's not as easy as it sounds. We'll spend some time with the M, mitosis phase. That's where you actually split the nucleus up. So you just copy the DNA, now you got to split those 2 copies so that you have the same copies on each side. Takes a little bit of time too. Okay, so DNA replication. Why do cells do it? To make new cells, right? To grow organisms, you have to add cells. To add cells, you've got to copy DNA of the cell, right? You have to do that. Why would you need to add new cells? To make an organism bigger, to replace worn out cells, to repair damaged cells, right? Cells have a limited lifespan. In fact, I think we talked about this before, but even like your body, which is made up of trillions of cells, most of those cells have replaced themselves within the last few months. So you're really never as old as you feel.